Hello my friend, happy to see you here. Welcome back to my channel. Today we have a really interesting equation n square minus n cube equal to 36. We need to solve this equation for n, so if you have your assumption, your solution, you can also write it in the comments below and then we will check our answers. Okay, so first of all, let's write the 36 on the left side. So let's do it right now. We have the same beginning, so we have n square minus n cube and minus 36 equal to 0. Right now, instead of the 36, let's write 27 plus 9. And a lot of students might be asking, why do we write 27 plus 9? Because 27, right here, I'm going to write it right here, 27 can be written as 3 times 3 times 3. So we can write it as 3 cube, yeah, 3 cube. And 9 is also a really great expression for us because we can write 9 as 3 times 3, yeah, 3 times 3. So we can write it as 3 square. And we have cube and square right here at this place, so then we can group it. Okay, so let's do it. So we have n square minus n cube minus, instead of 36 we write 27 plus 9 equal to 0. Right now let's open parentheses real quick. Let's do it. So we have n square minus n cube minus 27 and minus 9. And right now, instead of this 27, as I said before, of course we can do this instantly in this line. We don't need these two lines, but I want to solve this question step by step, so that's why we just solve it step by step. Maybe a lot of students here, so that's why. So we have n square minus n cube, and minus, instead of 27 we write 3 cube, and instead of 9 we write 3 square, so minus 3 square equal to 0. And right now, as I said before, we're gonna group. So we have n square and we have 3 square, we have n cube and we have 3 cube. So right now we're gonna group this together. So right now let's start on the left side. First of all, let's group our squares. N square minus 3 square. So we have n square minus 3 square. And right now we have minus, and let's group our cubes. N cube plus 3 cube. So minus n cube plus 3 cube equal to 0. So I really hope you understand this solution until this moment. So basically we just combine, we just express this, and we group squares and cubes together. Right now, what do we have right here in these parentheses? We have difference of squares, and let's remember this formula. It sounds really familiar. Everyone should know this school formula. So we have a square minus b square. So as a result, we have a minus b times a plus b, Really great. And right now, what do we have right here? We have sum of two cubes. We can also remember this formula. This is our school identity, a cube plus b cube. This is equal to a plus b, and right here we have second parenthesis, a square minus ab and plus b square. Really great. So right now, right here, let's apply difference of squares. Right here, sum of two cubes. So let's do this. First of all, n minus 3, n plus 3, difference of squares, n minus 3, n plus 3. Right here, what do we have? Sum of two cubes minus, we have n plus 3, and another parenthesis, n square minus 3n and plus 9 equal to 0. So I really hope you understand these steps. So we just expand these two expressions in terms of this formula. Okay, right now we have 4 parentheses, but the main thing, we have one same parenthesis. We have n plus 3, the same expression with this n plus 3. Okay, really great. And the next thing we're going to do, we're going to factor this n plus 3. Right here in the first parenthesis, in the first group we still have this n minus 3, so n minus 3, and from this group we still have this expression minus n square minus 3n and plus 9 equal to 0. Really great. Right now let's simplify this expression right here. Let's simplify this expression, yeah. So we have the same beginning, n plus 3, And in the next one, we can actually get rid of this parenthesis. So right here, we can actually get rid of it. So we have n minus 3. Right here, we can write it as minus n square plus 3n and minus 9. We just need to change all the signs to the opposite one. So equal to equal to 0. Really great. Right now we can actually simplify right here this second parenthesis, and we can see that this is our quadratic equation, but we need to change an order. We need to do this because we have a square, so we have and, we have a constant, so it looks like a quadratic equation, yeah? So we have the same beginning, n plus 3 in the beginning, and in the second parenthesis, we have minus n square on the first position, minus n square on the first position, 3n plus n, so plus 4n, plus 4n, minus 3 minus 9, we have minus 12, equal to 0. And right now we can actually say, okay, we factor our question, we have a product of two parentheses, and a product of two parentheses equal to 0 when the first parenthesis is equal to 0, so n plus 3 equal to 0, or the second parenthesis equal to 0, or this one, so the second branch, minus n square plus 4n and minus 12 equal to 0. But this one I recommend you to multiply by minus 1, okay, for better order, because we have a negative sign. My quick recommendation, just multiply it or divide by minus 1, and the next we have n square minus 4n and plus 12 equal to 0. Really great. So right now let's solve. We have two branches. We have first linear equation, so we can write that our n first equal to minus 3 real quick, n first equal to minus 3. Yeah, let's do it. Let's underline it. This is our real number root. And we have the second equation. Second equation, this is a basic, a classic quadratic equation. Of course, this is up to you how you prefer solving this equation. I'm going to use this basic and classic method of coefficients. So a equal to 1, b equal to minus 4, and c equal to 12. So let's find real quick our discriminant. So we have b square minus 4ac equal to b square, so minus 4 square minus 4 times a times 1 and times c times 12. So equal to, we have 16 minus 4 times 12. We have 48. So our discriminant is less than 0, so we have minus 32. So it means that right here we have two complex roots. In this branch we have two complex roots, and let's find it. So n first is real number root, but n second and third. So let's start, for example, right here, n second and third, these two roots going to be complex. So we have minus b plus minus square root of discriminant and all over to a. So let's plug in each of these elements into this spot. So minus b minus 4 plus minus square root of discriminant, so square root of minus 32, and all over 2 times 1. Right here, square root, right here, minus, we have plus, this is our multiplication, 4 plus minus, square root of minus 32, we can easily write it as square root of minus 1, because this is not a table case, and we have to split this negative sign because this is our complex root right here. So this is our square root of minus 1 times 16 and times 2 all over 2 equal to, okay, the next thing, 4 plus minus, right here there's a really interesting and a great property. We can write it as square root of minus 1 times square root of 16 and times square root of 2. We can split it, so we can write it as square root of minus 1 times square root of 16 and times square root of 2. Okay, it works perfectly with the multiplication and division, but not with addition and subtraction. Okay, equal to square root of minus 1, this is our imaginary unit, this is our I, square root of 16 equal to 4. So we have 4 plus minus 4i square root of 2 all over 2. And in the end, of course, this is up to you how you prefer solving this question. My quick recommendation is to divide by parts. So we're going to divide 4 over 2 plus minus 4i square root of 2 over 2. And right now we can say, okay, right here we have 2 plus minus 2i square root of 2, so we're going to cancel this one and this one, 2i square root of 2, 2i square root of 2, and these are our two complex roots. And right now let's gather all the roots together, and let's write our final answer to this question. So our answer, so n first equal to 3 from here, so n first, let's group it together, so n first equal to 3, and n second and third equal to 2 plus minus 2i square root of 2. Okay, so these are two complex roots right here, and this one is real number root. And in the end, a few thoughts about this question, and let's check real quick our n first equal to -3. Yeah, but right here we have -3. Yeah, so it's really great that we see that -3 because there's a big difference between that. So let's check real quick. Our -3. First of all, let's rewrite our question. So n square minus n cube equal to 36. Right now n square, so we have -3 square. So right now we check real quick our n first equal to -3. So we have -3 square minus -3 cube equal to 36. Okay, really great. Right now -3 square equal to 9, minus with this minus because right here we have an odd power, so it will be plus, and 27 equal to 36. So our root is absolutely correct, and of course a correct answer. And I really hope you understand this solution. Also write your thoughts, write your comments. What do you think about this question? And if you're really interested in tricks, right here we have a cubic equation. So it means that according to the fundamental theorem of algebra, we have 3 roots. Okay, we have first one and two complex root. It's extremely important thing to prove sometimes, because a lot of students might be thinking maybe I forget something, maybe I find more roots than expected. But quick recommendation: according to a fundamental theorem of algebra, we have the third power cubic equation. It means 3 roots in total. We don't know exactly how many real number roots, how many complex roots. 1 real, 2 complex. This is our case. It depends on equation. It can be like 3 complex, 3 real sometimes, and a lot of interesting things. Even right here we have a quadratic equation, so it means 2 roots right here, linear function, 1 real root. So this is extremely important part. And in the end, my quick recommendation, because a lot of students try to solve these basic equations with the inspection method. They try to think maybe 1, 2, 3, -1, -2, -3, and they say n equal to -3 is a correct root. But with this method, you forget about complex root. So every time you have an equation, try to solve it, try to think a little bit about it. This is, of course, if you don't have a time, you can solve it by inspection, but just remember that you forget about another part. You forget about these 2 complex roots. You should know how can we solve this type of question. And if you still have any question, write a question in the comments below, because this is not the hard question. This is a basic question with few really interesting tricks right here. So this is our first trick, so we can group cubes and squares, and then we have to remember these 2 formulas. And my quick recommendation: try to learn this algorithm, try to learn this principle, because this is not the hard question. And I really hope every time you have this type of equation, you will be successful at it, because this is extremely great to learn something new and to practice this type of question. So I wish you all the best in life. Take care of yourself. Have a great day. Write your thoughts, write your response about it. I really think and I really hope that this video is helpful in any way. If you struggle with the basic math, with the Olympiad mathematics, I have more than 600 videos on my YouTube channel, so you can easily practice different type of questions, not only like equation. I have a lot of radical questions, very basic material, very basic things here. So I really hope you enjoy it, and I really hope this channel is extremely helpful. And I want to say thank you everyone for being here. A lot of teachers here, a lot of students here, and we have this type of community. It is extremely great that we learn something, we exchange information, and it's extremely great. So take care of yourself, have a great day. Write your thoughts. What do you think about this question? What do you think about this solution? Write your solution. It's also really great to see this type of question from your perspective. It's also really great. So wish all the best in your life. Take care of yourself and have a great day. See you in the next videos.